Happy learning to all. Today we will learn something about latches. So starting with sequential circuits. A sequential circuit will contain both combinational part as well as memory element. Memory element, in the sense, it can be achieved by positive feedback, which is nothing but static in nature, and it could be achieved by starch storage mechanism, which is called dynamic memory. So static means positive feedback has been applied, in which some part of the output is given to the input, as well as long as power is applied, the memory will be retained in the cell. In the case of charge based, the MOSFET is considered as a capacitor, where you are going to store some charges in the capacitor, in the node capacitors. So that is considered to be starch storage mechanism in the case of dynamic memories. So when you work with sequential circuit, you are worried about fixing the clock frequency. So when you work with this type of system, where combinational as well as memory element is there, memory element is required to remember the whatever is previously happened in the system. So clock frequency is determined as T should be, which should be greater or equal to T setup plus TP combinational and TP flip flop. So we will see what is that. So when you work with flip flops, the setup time is the time required for the flip flop before which when you consider flip flop, the input should be applied before the clock edge. That is called as setup time. And the minimum time, or the combination circuit, in worst case, what is the amount of time it is going to take, is considered to be TP combination. Propagation delay in the combination circuit is called TP com. It is nothing but propagation delay in combinational circuit. And TP flip flop is nothing but, TPFF is nothing but propagation delay in flip flop. And setup time is the time before which the input should be applied to the clock before the clock arrives into the flip flop. That is called as setup time. And the worst case propagation delay through the combinational block, and TP flip flop is propagation delay through the flip flop. So this is to be considered when you fix the frequency of the system. T is going to determine the frequency of the system. That is how we are going to fix the clock frequency. So T is inversely proportional to 1 by F. So if you determine T, you can determine the frequency of the system. So the system depends upon the setup time of the flip flop, combinational delay, which is nothing but propagation delay through the combination circuit, which is to be considered where the worst case is to be considered. We have to consider the worst case delay, as well as the propagation delay after the clock has been applied. What is the amount of time it is going to take for the flip flop? Suppose if I give 1 here, this is to be copied as 1. So that is called as TPFF, the propagation delay through the flip flop. After the clock edge, the input has to be copied to the output, which is nothing but Q. C is nothing but after the clock arrival, the input has to be copied to the Q. That is called as C to Q, and which is nothing but TPFF. Next is, we said that in the first slide, we said that the positive feedback is to be used in the case of static. So we consider the inverter. So we are cascading the output. We are making a connection between two inverters in cascade fashion. So this is the transfer characteristics of the first inverter, and this is your second transfer characteristics of the second inverter. Both are being cascaded. So the difference between this graph and this graph is the plot is rotated to accentuate that VI2 is equal to VI1. Both the graphs are one and the same, but in the case this is the output, this is your input. but in this graph this is your input and this is your output, and when you combine both the graphs together you will get this point, and A and B are nothing but stable points, C is nothing but it is called meta stable point. So a flip-flop should be either staying in either it should hold a value of 1 or either 0. That should be the case. Sometimes the flip-flop will be sitting in metastable state where a small disturbance when it is applied to the C due to loop gain, because it has been cascaded, it will either go to state A or it will go to state B due to loop gain. So in this case the loop gain at point C, the loop gain will be maximum, and point A and B will not have much loop gain, which is less than 1, so they will be considered as stable state because the loop gain is less than 1 in stable state A and B. In case of metastable state the gain is maximum, so when you have a disturbance it could either go to stable state A or it could go to stable state B. That is what is being explained here. We will go into SR flip-flop. So this is constructed using SR. So in the SR type flip-flop where we are going to consider NOR gate. So in the case of NOR gate, if both the inputs are 1, so NOR gate, so 0 0, output will be 1. So 0 1, output is 0. 1 0 0 1 1 0. If both the inputs are 0 and 0, so first case both the inputs are 0 and 0, and previously we considered this is to be as 1 and this is to be considered as 0. We assume it could be either case, q bar can be 0 and q could be equal to 1. We assume that this is the case. So one input is 0, the other input is also 0, so it says that q bar is 1. So the first NOR gate is going to produce output 1, which is nothing but q bar. When you consider the second NOR gate, the one of the input is 0 and the other input is going to be 1, so this 1 is going to go and output is going to be 0. So when you give 0 and 0 to the NOR type SR flip-flop, it is going to retain previous state, or it could be called as memory state. The other case, so we are going to change it as 1 and this is going to be 1. If both the inputs are 1, the Q, that is the output of first NOR gate, should be equal to 0. The second NOR gate should be also equal to 0. This is violating the rule of Q and Q bar. They should be complement to each other, but this is not the proper operation of a flip-flop. So this condition 1 and 1 is forbidden or prohibited in SR type. That's why we are going for other types of flip-flop. So when you go for a NAND type SR latch, similarly if you apply the same principle, 1 and 1, the input 1 and 1 will retain the memory state. So whatever is the previously stored value, that will be stored here. When you consider 0 and 0, this is forbidden, right? This is to understand SR type flip-flop. Next is, we are going to take SR flip-flop. When you look at the circuit, this circuit, it contains 4, so this is nothing but an inverter. So this is M1 to M1 to M4. They are nothing but the cross coupled inverter. you have extra 4 transistors to drive the flip-flop from one state to another and to provide clocked operation. So M5, M6, M7 and M8, these are the extra transistor to program SR type flip-flop, and this technique is called overpowering technique. The drawback of saving some transistor over full complementary CMOS implementation is that transistor sizing should be critical in ensuring the proper functionality. So we have made 4 transistor extra. These transistor from M5 to M8 should be properly ratioed so that the value of Q and Q bar will be changed according to S and R input values. That is the drawback of this circuit, and this type of technique is called overpowering technique. So this is the circuit. Consider the case where Q is high. So we consider that Q is high. So it says Q bar is 0. When R pulse is being applied, so it is being equal to 1, and this is being equal to, clock is being equal to high. So when this is the case, M4, M7 and M8 is going to form a ratioed inverter. In order to make the latch to switch, we must succeed in bringing Q below the switching threshold of the inverter M1, M2. So this transistor will have some threshold voltage. When we consider CMOS inverter, we studied V inverter of the threshold voltage of the inverter, which would be equal to VDD by 2. So this 2 M4, M7 and M8 should be ratioed in such a way that the inverter voltage should be brought below this VDD by 2, so that the Q and Q bar is going to change. Once this is achieved, the positive feedback causes flip-flop to invert state. This requirement forces to increase the size of transistor M5, M6, M7 and M8. This is to be considered when you work with SR type overpowering technique. And with this, we end up this short video. Thank you all.